like I killed your puppy, and then when I gave you time to work, some of us weren't as productive as I would have preferred. So I would like for today to mostly be a work day for you to get to practice with Piecewise, but if we're not going to be productive, you know I'm going to keep talking math, right? So I'm still being rebellious. Everyone else is quizzing before me. I don't like being behind, by the way. I'm not saying that, but we're not going to quiz on Piecewise till next Tuesday. We're taking a quiz next Tuesday. There's a checkpoint for Piecewise. We'll start it on Friday. Probably have to wrap it on up on Monday. Today is only Thursday, so we're fine. We're going to breathe air. We're fine. The Homer Simpson puzzle is okay. You haven't finished it. When I stopped rambling, that would be the first thing you want to finish, and then show me. I finished my Homer Simpson puzzle. There were specific problems you could skip. If you've forgotten that or forgot what the answer was supposed to be, it's written on the board. The chocolate chip cookie does. So yes, Seth has the answer. So I'm not looking to see does he spell it out right on the tag. I'm looking to see does he have some math. Did I actually see him evaluate? Now I get some evaluations can happen in your head, but a lot need to happen on paper to show me at least Patrick knew which function to plug it into when we have options. He has to make the right decision. So, we're back on Piecewise. I feel confident that you can evaluate. I still feel a little stressed about you graphing. And then there's one more piece we need to save, and we'll save it till tomorrow, because if I say domain and range today, I really think you might cry. So we'll save that till tomorrow. So when I get done rambling, you'll do Homer Simpson. So if we made a list of stuff I want from you today. I want Homer Simpson. It's a different puzzle. I'll have to look at what it's called in a second. And then, of course, you could always work on your homework. It's not due till Monday, but man, Will wishes he would have it done as soon as possible, especially since it requires graph paper. Okay, do you have the second page of the puzzle yesterday? Somebody?
What's in between Godzilla's?
Yeah, thank you. Okay. The second one that we're going to do is actually the horses. And you can skip Godzilla. You can skip Godzilla. Now, if Day wants to do Godzilla for, remind me to give it back to you. I hold on to it, but I'm the worst at stealing things. If Day wants to do Godzilla for bonus, she can. But I'm not going to demand Godzilla. We'll talk about how to do those two in just a second. Let's go ahead and get these math workshops out the way. Math workshops kind of look like piecewise functions put together. In my mind, I kind of already imagine a fence here and here. And then they were arguing over these points. But that's just me trying to go all mathy on you. So we see this graph. It says meters on the y-axis, seconds on the x-axis. And we're supposed to write a description for a walk that will produce the graph.
Got it.
Okay. I would love to hear something.
I said the person walked at a speed that's higher and then started walking at a constant speed. And then, he slowed down. Oh, you want more like definitions?
No, I don't want more definitions, and your group can have a point. Because I liked the fact that he recognized that it was an increase, then constant, and then a decrease. But he said, in the middle, he said the person was walking at a constant speed. Is that actually what's happening?
Oh.
What's happening between 2 and 7? He stopped. So I'm really going to write 3 sentences. My middle sentence is, we're going to call him he. It could have been a she. I'm sorry. He stopped walking between 2 and 7 seconds. Or you could say he stopped walking for 5 seconds. So this is the dumbest walk ever. Because it's only 10 seconds long, yet you and I are writing a story about it. How awesome are we? So he stopped walking between 2 and 7 seconds. Okay, I agree with Seth that at first he was increasing. Could we be more specific about that increase? Can we tell me how many meters per second he was increasing by? I mean, he went 2 meters further in 2 seconds, so he's traveling about 1 meter per second. Because he went, he went 2 meters further. He went from 1 to 3, but he did that in 2 seconds. So he could say, starting at 1 meter, he traveled 1 meter per second. But I get that I'm a math teacher and I made that super mathy. So Seth and Ben's of just his increase, or somehow stating that he was walking forward, that was sufficient enough. Okay, and then so we addressed the middle part of the graph. We addressed the front part of the graph, and now we've got to address the end of that graph. What he was doing those last couple seconds from 7 to 10. Seth said that he slowed down, which is true because I've colored them pink and brown. That pink line is way steeper than that brown line, so it's true he did slow down. Table 6, you can have a point, by the way, because you helped. He did slow down. Where did he end up? He ended up back where he started, so you can have a point for that. So I'm going to say he ended at 10 seconds back where he started. And then if Addison wanted to be an overachiever, she could even tell us the rate of change that was occurring from 7 to 10. So how fast was he going? It was not 1 meter per second. Yes, dear. Yes. And he held up his hands and you said it out loud. So 1 and 3 can have it. He was traveling, so he went 3 meters in 2 he went 2 meters in 3 seconds. So it's 2 over 3 would be his rate of change. So I'm going to say he traveled 2 meters in 3 seconds. But again, Miss Compton's being an overachiever with her words. I'm sure a sufficient description, like the one that Seth gave, would have been sufficient to begin with. The only thing we were mad at with Seth's original description was the fact that he said the guy walked at a constant rate when it was a straight line. And no, Seth needs to readdress that. He wasn't moving between 2 and 7. He stood there. Now, why we're writing a story about this 10-second walk, that is beyond me. Okay, so then our last bell ringer question, which you know is not our last one because we skipped 1 through 6, but our last one for today says that Kimmy thinks that the graph and table below are representations of the same linear relation. Carla disagrees. Who is correct? Explain your reasoning. Who is correct? Explain your reasoning. So is Kimmy or Carla correct? Kimmy says they both represent the same relation. Carla says they don't. You say Kimmy is correct. Kelsey, you say Kimmy's correct as well. Anyone want to argue for Carla? No, we're all going to argue for Kimmy? Okay, does anyone have a reason? Because it says explain your reasoning. Is that what you were going to say? Okay, 1 and 5. Braxton, do you have something else to add? 0, -1, yep. 1, 1, yep. 2, 3, yes. And then 3, 5, probably looks like it, can't really tell. Now, I think Braxton explained what Addison and Kelsey were thinking with better words, but there is another way we could prove this to ourselves. There's another way. We just took a test on this.
What's it called? Put the x's on top. No, the y's on top and then divided by x's.
Using this table, can you help me do it? And we'll call it rate of change. Yeah. Where they change by each time on the axis. Where they change by each time on the y. So what is my rate of change, which is another word for slope? 2 over 1, which is just 2. So we know the intercept was at -1. So are we actually going up 2 over 1, up 2 over 1, up 2 over 1? Hot dog, we are. So Kimmy, and then if I could use words, but I'm out of brain power. Kimmy is correct, and you could argue from the rate of change we calculated, or you could do the way Addison, Braxton, and Kelsey were doing and argue that the points in the graph matched. Yes, point for, I don't know, you and 5 are on it today. How many do y'all have?
4.
5, do y'all have 4?
Yeah.
You can go to 3. Okay, are there any questions about this math workshop? We went real deep. Okay, get out your cute doodle notes for Piecewise. Okay, I realized after you left me and that you looked at me like I had killed your puppy that we need to spend some more time on this, which is fine. Just a brief reminder. So we like evaluating with Piecewise. You're even going to like domain and range. My least favorite part with Piecewise is actually physically drawing the graphs. It's my least favorite part too. Takes time, it gets annoying. So we had 3 steps to try to make our life easier. Our first step is that we draw fences. We look at our inequality. For instance, with our example on the front page, we looked and we saw there was going to be an issue at -3, there was going to be an issue at 2, so we drew our fences at -3 and 2. And just like you with your neighbor, eventually we argued over the points on that fence line. Okay, step 1, we drew our fences. I normally in real life draw my fences using a solid line or a dotted line. Paige said it first, her group gets a point. I normally use a dotted line. I'm just using solid because y'all can't see it if I do dotted. Okay, so we draw our fences. Our second step is probably the most important step. We graph with a pencil. And then our third step is we argue over the points on the fence. So we argue over, does the blue line, I eventually colored things, as I always do. So we argued over who owns this purple fence. Does the blue own it or does the pink own it? And that depends. How do you decide that? You look at the inequality, and if it's equal to, you fill in the circle, and if it's not, you don't, and your group gets a point for that. Look at you getting back to 5 today. But you need extra because you got to make up for yesterday. Okay, Mr. Moore is a little smarter than me sometimes. Don't ever tell him I said that there. So he actually even writes it out as, so he doesn't even bother to graph. You know how I graph extra and then erase because I'm slow? So he actually doesn't even do that. He in his mind, he realizes with the fences that the top one's going to be the left of the fence, the middle one's going to be in between the 2 fences, and the right one's going to be to the right of the fence. So he doesn't even bother to graph. Like when we did y = 3, you and I graphed it way over here, and I can still see my erase marks. He would never bother to do that. He understands left, middle, right. Okay, so you're going to do one example, and then it's your turn to handle your life. Because Lord knows you got stuff to do. So let's see. Step 1, I want to draw fences. Where am I going to put a fence in this example 2? Where am I going to put my fence in example 2? -7. Every group can have a point. We see that -7 is where the issue is going to be. I put my fence at -7. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to make my fence dotted for once. Maybe you'll notice it. I don't know. Oh, yeah, that worked. That worked. Okay, my step 2 is supposed to be graph with a pencil. I've got to go pick up my pencil. Can someone explain in English how to graph that top line? Where did I put my first point? What's going on? Okay, Kelsey said to go to 6 and then go up 2 over 3. Some people I've noticed in other class periods, I hadn't really watched you graph, I'm going to today. Some people in other class periods are having issues with where to put the 6 at. Do we put the 6 on the fence, or do we put the 6 on the y-axis? Yes, so if you need to write the two things out, we're graphing two equations. We're graphing y equals 2/3 x plus 6, and we're graphing y equals negative 6x in this example. So if you need to write it out in slope-intercept y equals mx plus b to make your life easier, you can. And if you need to think through P.S., this one's going to be to the left of that blue fence, this one's going to be to the right of that blue fence, you can. That's fine. You have brains. We've done this for a couple days. It's fine. Okay, so I go up to 6, she said. 1, 2, 3, 4, 5, 6. Kelsey, you can have a point for that. She said the slope was 2/3, so I go up 2 over 3. Up 2 over 3. I go down 2, left 3. And what really, really, really stinks about this example is that when you and I get to erasing, we're going to erase most of our hard-earned work right then. Okay, does everyone understand how we graph that line? Are there any questions about how we graph that line? It will not hurt my feelings. Okay, I got the look, so let me say it again. It was 2/3 x plus 6, so we went up to 6. 1, 2, 3, 4, 5, 6. We put our first point. And then since our slope was 2/3, we went up 2 to the right 3. We also went down 2 and to the left 3. And just a reminder, positive lines lean to the right, negative lines lean to the left. I always have to ask myself that. Is my line leaning the right way? Okay, what am I going to do from here? I'm going to erase a bunch of stuff. Which side am I going to erase? I'm going to erase the right side. I don't need it until we get to that fence. I mean, I don't need it after that fence. So I'm erasing a majority of what you and I just did. So let me see. It was down 2 over 1, 2, 3. Down 2, 1, 2, 3. So, and it's not even hitting that fence at a pretty point, and that's okay. I don't really care. Life's hard. It's not always going to hit at a pretty point. Okay, at this point, that's normally when I color code my life, and I'll say this top one is the pink one. When we get to this fence mark, is this pink line going to win the battle? Am I going to fill in that circle?
No.
Why?
Because it's not equal.
It's not equal to. Okay, so we've graphed half of it. We only have the other half left. It is negative x. How do I graph y equals negative x? Where do I put my intercept? At 0, because it's negative x plus 0. I heard a bunch of people say it. We're probably about to go all get a bunch of points. We can help me finish this. Okay, my slope is negative 1. So do I go up 1 and right 1?
No, down 1. To left.
Down 1, left 1. Are you sure? Oh, okay. Back to, I'm serious. I have to think through. It's supposed to lean to the left, and the way y'all were telling me it was not going to lean left. Because it was negative x. So I know it's really y equals negative 1x plus 0. And if you want to write it out like that, that's not a problem. So I knew my intercept was at 0, and my slope was negative 1. Now, I was thinking all that through in my head, but writing it out is not a bad idea. Okay, and then I'm a little slow, so I'm going to keep on graphing. Oh, and I graphed the world. I graphed all the points. I'm going to connect all the dots. But I didn't have to do all that, did I? Where should I have stopped? You could stop at the fence line. Okay, I'm going to give him a color. I'll let him be brown. Should the brown guy win the battle, should I fill in his circle? On that fence line, do I fill in his circle? Why?
Because it's equal to.
Because it's equal to. Okay. Do you see how you're bored of me going over this? Because you've got it? You realize you have to practice it. Okay. So I'm telling you don't have to do. So a reminder of things you do have to do in life. Homer Simpson. Have you finished Homer Simpson? If not, first up, do Homer Simpson. So let me pull that list back up on the screen. Okay. Have you done the Homer Simpson puzzle? If yes, great. Show it to me. It's a grade. If not, work on Homer Simpson when you're grade. I should see let me say this again. I should see everyone's completed Homer Simpson for sure before they leave the room today. There's no way you don't finish Homer Simpson today. Especially when we took off some problems and I gave you the answer, which is again over there on the board. You do not, yesterday I passed out 2 pieces of paper. You do not have to do the Godzilla side. If you want to figure it out and ask me, I'll help you with it. But you do not have to do the Godzilla side. However, you do have to do the horse side. But lo and behold, Gracie doesn't even have to graph on the horse side. If she pays attention, she's just trying to match a piecewise function to its graph. So she's just matching. Gracie can match all day long. And then if somehow Gracie can do it all, she can finish the top 2 things. Lord knows she should do her homework, especially those graphing problems. They're originally 16. I think we took off 3, so you have 13, which is not a lucky number. It's not due till Monday, but clearly the graphing takes time, so Gracie needs to get on it.
Gracie is not.
Okay. I know some people didn't see their test either, so we'll work on that as well. Work on one of the things, people.